All right, so we're here on 2.1.6 of the lithosphere of key question 1. So this is the rock cycle. So this will be the last one that we do in the Earth section, chapter, whatever you want to call it. All right, so the rock cycle. The lithosphere and all of Earth's crust is constantly slowly being formed and recycled from the molten rock in the mantle. We saw this back a couple sections ago when we talked about the plate tectonics, where one will subduct, and then at the convergent boundaries and then at the divergent boundaries, new crust will be formed. That continuously rotates in there, and basically this process creates different types of rocks and is known as the rock cycle. These processes are part of the rock cycle, the way that rocks change and are recycled within and on the Earth. There are three basic types of rock. The first type you need to know is sedimentary. Sedimentary rock is formed from sediments. You can see that definition there if you need to. Maybe eroded fragments of other types of rocks from dead remains of animals, like fossils, or from solutions on Earth that form solids via chemical reactions. These are called precipitates. All right? They can be deposited through a process called deposition on both land and an aquatic environment. So basically, if it's dissolved somewhere, it can be then deposited somewhere else after it dries out of the solution, comes out of the solution. The most common sedimentary rock is limestone, also known as calcium carbonate. It's formed in marine environments and is a source of many fossils. It doesn't have to be found underwater, though. It can be formed in marine environments, and then if those marine environments become terrestrial, it becomes land-based. We have a lot of limestone in Florida because of this, because Florida at one point was covered by water. Sediment accumulates over thousands of years and can be hundreds of meters thick. The pressure of this rock on top of rock is so immense, all right? So you have rocks formed in layers, so over time more rocks would go, and that creates a lot of pressure on the lower layers, and it can cement it together, all right? And that can result in sedimentary rocks such as sandstone and limestone. Examples of sedimentary rocks include conglomerate, breccia, shale, halite, gypsum, coal, and more. You can look at these on the link on this website and see what some sedimentary rocks are. I do have a picture right here of limestone. You can see very rocky, definitely looks like a bunch of different things fused together. Not very consistent. Those are all typical of sedimentary rocks. Things that look like they've been fused together, because basically they have over thousands, hundreds of thousands, millions of years, right? Igneous. That's the next type we're going to talk about. Igneous forms when magma, which is molten rock, cools and solidifies. Magma is what happens when it's in a volcano. We'll talk more about this in the next section. So you have a volcano, all right? This is magma. Once it reaches the surface, it's called lava, all right? So lava is when that molten rock comes out of the volcano. Same stuff, different location. But if magma, actually, it can cool and solidify if it gets close enough to the surface, but it might still be inside the volcano. That can form igneous rock, so it'll form inside the Earth still. All right? Usually forms beneath the land surface, like I said, and this is called intrusive igneous rock. All right? Inside, beneath the land surface is intrusive. Intrusive igneous rock cools slowly since it's below the surface and forms large crystals. So if it's below the surface, it's still going to be fairly warm, and so it's going to take a long time to cool down because it's still pretty warm under there. It's just not hot enough to keep it liquid, the magma liquid. So it's going to form, and it's going to make these big, nice, long crystals. So examples of these are granite, all right, pegmatite, gabbro, diorite. You can see an intrusive igneous rock right here. This is granite. I don't want you to take it for granted. All right, so we have the granite there, and that is an intrusive igneous rock, and you can see the larger crystals, and you can actually see the crystals go out. Some of you may have granite countertops. Those have been smoothed down. You go look at those, and you can actually see the large crystals in there that have formed when it cooled down. Some molten rock does make it to the surface and cools rapidly, so this would be lava, but then when it cools like super fast. Because it reached the surface, which is a lot cooler than the inside of the volcano. So this is called, or not just a volcano, but fissures in the earth. Some of this molten rock is called extrusive. So outside, when it cools outside, it's called extrusive at the surface. All right, and these are going to have smaller crystals because of the rapid cooling. So rapid cooling causes things like, the longer cooling will cause these crystals to kind of like form out over a long period of time. Rapid cooling, whatever's there's a and basically forms these smaller crystals. Examples include andesite, basalt, obsidian, pumice, rhyolite, and scoria. And you can see information on those at that link. Let's take a look at that real quick, just so you can see. So you can see igneous rock here. All right, there's andesite. All right, you got basalt, dacite, diabase, all kinds of different ones. Gabbro. Gabbro's intrusive igneous rock. Let's find a extrusive. You can see here's an extrusive obsidian. Intrusive, lots of intrusive types. And there's an rhyolite. You can see not as much mixing because basically it's just like whatever comes out is formed. And so you don't really see many crystals in there. Everything's kind of super small inside there. All right, next. We've got metamorphic rock. That's the third type. And that's formed when igneous rock or sedimentary rock, can be either one, is under extreme heat or pressure. What will happen is that this rock will form from that. It metamorphs from the previous rock type, whether it's sedimentary or it is igneous rock, will form this metamorphic rock. All right. It can happen at plate boundaries because there's so much heat and pressure happening at those plate boundaries that can cause this to happen, or when in contact with magma. So if there's a hot spot or some kind of magma underneath, even though that magma could eventually form its own igneous rock, if there's enough heat pushing off of that, it's going to be able to turn whatever that rock is, maybe that igneous rock that's already underneath there, into metamorphic rock. Some metamorphic rock forms in layers. This is known as foliated metamorphic rock. So if it's in layers like an onion, all right, you're going to have foliated metamorphic rock. This is an example of foliated metamorphic rock. It's called gneiss because it sure is nice. All right. Other metamorphic rock has no apparent ordered structure. So if you see it and you know it's metamorphic rock and it's not made into layers, this is known as non-foliated metamorphic rock. It would look basically like a bunch of things just mixed together, not in layers. An example of this is marble. If you've ever seen marble, definitely no layers in marble. And so that's formed from sedimentary limestone under extreme heat and pressure. And obviously it's different from limestone. You guys, I'm sure, have seen marble columns and stuff in the ancient Greeks and stuff like that. And oh, look, a nice pun. Wow, this stuff rocks. And more metamorphic rocks are available on that link. All right. Now that you know the different types of rock, you may be able to put together the whole concept of a rock cycle. So how does this all cycle? But before we look at the big picture, there are three primary processes that happen within it that need to be familiar with. Denudation. This is the process by which rocks are weathered and eroded. And so weird word, but it's basically the breakdown of rocks. And it can happen still in place, or it can happen in a process where it moves. If it happens in place, in situ, it means they stay in place. This is called weathering. Three different types of weathering. Chemical weathering. That's where something happens. Usually in air or water, we'll have some kind of chemical, whether it be an acid or something that's going to break down that rock. That's actually going to change the chemical composition of that rock, like some of it dissolves or something like that. Okay. Mechanical weathering is the breaking up the rocks, but it's basically like taking a rock and breaking it in half into smaller pieces in place. This would be mechanical weathering. This can happen many different ways. Earthquakes, whatever you think that could break a rock. And then biological weathering is kind of mechanical weathering, but it's under biological processes. So it's be like a root coming up and breaking apart a rock, or an animal burying it into the rock itself. And so burrowing is the word I was looking for there. Into the rock itself, and that would break up the rock. So remember, that's all in place, is weathering. Now, if it happens over a distance, all right, involving movement, That's called erosion. And erosion usually happens due to wind. So wind will come by and take pieces of rock and move it to other places, break it up and move to other places. Waves hitting the shoreline, rocks will eventually erode those. Streams, rivers, glaciers, they all are different ways of eroding. Next is transportation, and that's the process of erosion. That's just basically the process that carries sediment or other materials away from their point of origin. Transporting media would include wind, water, or mantle, convection currents, and does not break down the rock itself. So this is not erosion. I think I may have just misspoke. This is not erosion. This is just picking up and moving rocks, where this would be actually breaking them apart as well. And deposition is when the materials settle out from wherever it's transporting them. So if a stream's taking that rock, wherever it ends, that's where it's deposited. That would be deposition. All right, last thing we're going to look at is the rock cycle, now that we know all those terms. Now let's take a look at this. All right, I made this a few years ago, I think. Oh wait, no, I did not make this one. But let's take a look at the rock cycle. And you can play around with this yourself as well. All right, so the rock cycle, we're going to look at how igneous rocks are made. You can see that they're made underneath the surface. The volcano, it comes out, and the rock is either cooled underneath the surface or above the surface. All right, melted rock is called magma. When magma hardens, it makes igneous rocks. Most igneous rocks are found underground, from underground. Some igneous rocks come from when volcanoes erupt. There they are. All right, not all rocks are igneous though. We'll look at some rocks are smashed and baked but not melted. After thousands of years, intense heat and pressure makes new rocks. And these rocks are called metamorphic. There's some examples of metamorphic rocks. And there one more way rocks are made, and that's sedimentary rocks. All right, water breaks big rocks into little rocks. Doesn't have to be water. Little rocks break into pieces of sand. All right. Then over thousands of years, the grains of sand get cemented together and form brand new rocks. And this process creates sedimentary rocks. Here's some examples. All right, these changes are a cycle. They happen over and over. And you can see right there, igneous, metamorphic, and sedimentary rocks. And you can look at the rest of that on your own, but I'm going to go back to our one here. And you can see this is a good example of the rock cycle. You've got metamorphic rock, all right, and we can start there. The metamorphic rock can be melted, all right, and during that melting, it turns into magma, all right, and then when that magma cools, that becomes sedimentary rock, or igneous rock, I'm sorry, all right. Now the igneous rock itself can melt, form more magma, and cool again, and form igneous rock again. Now, the igneous rock also, so it can form different ones, basically. If it happens inside the volcano, it's intrusive, outside extrusive. Could be from the same parent material. Now, if that igneous rock, though, is subjected to heat and pressure, maybe at a mantle core, or not a mantle core, at a subduction zone, under heat and pressure, that could form metamorphic rock again. All right? Now let's go back to this igneous rock. Now this igneous rock, if it's just left alone, and subjected to weathering and erosion, will form sediment, all right? That sediment will be compacted and cemented and will make sedimentary rock. So these are our big three right here, right? The three that are circled there, all right? Then if that sedimentary rock is under heat and pressure, it can form metamorphic rock. The sedimentary rock also can be weathered and eroded and made back into sediment. All right. The metamorphic rock also can turn directly into sedimentary rock as well. Basically, they all can turn into each other. You can even have sedimentary rock, if it gets far enough down, turn into magma itself. So you could even have an arrow going like heat pressure, or melting basically, and then go into magma. So that could happen as well. So all this can happen. This is basically the rock cycle. It's pretty simple in concept. Yes, it can go many different ways, but your basic thing is you need to know what metamorphic rock is, what igneous rock is, and what sedimentary rock is, and how basically they turn into the other ones. All right. And that's it for the rock cycle, and that's it for key question 1 in the lithosphere, so 2.1. That's the final one. And I'll talk to you guys next time.